Namaskar and I welcome all of you to my YouTube channel. Students, as you know, our event semester classes at college resumed on 17th January 2025. To support your learning, I have decided to upload the contents that I am teaching at my college. Currently, I am covering the contents of electromagnetic theory paper. So, in my upcoming lectures, you will receive the contents of electromagnetic theory. Since this is my first lecture on electromagnetic theory, so let me review some basics of vector calculus, because vector calculus is the backbone of electromagnetic theory. That means you must have good command on vector calculus before understanding electromagnetic theory. So without further delay, let's get started. The first concept that you need to know is what is a field. Students, a field is basically a region in space where each point is assigned by a scalar or vector quantity. If each point is assigned by a scalar quantity, then this field is known as the scalar field. However, if each point is assigned by a vector quantity, then this field is known as the vector field. So, from this explanation, we come to know that fields are of two types. First one is scalar field and the second one is vector field. Some examples of scalar fields are temperature field, pressure field, etc. And some examples of vector fields are gravitational field, electric field, magnetic field, etc. Next concept that you need to know is del operator. In Cartesian form, the del operator is defined in this way: I cap del del x plus j cap del del y plus k cap del del z, where I cap comma j cap comma k cap are the unit vectors along x comma y and z axis. When this del operator operates on scalar field or scalar function, then we get the gradient. Again, when this del operator operates on vector field or vector function via dot product, then we get the divergence. Again, when this del operator operates on vector field or vector function via cross product, then we get the curl. In my next section, I will explain gradient, divergence and curl in detail. Okay? Now, let me define the concept of gradient of a scalar field. Students, in my previous section, I already mentioned you that when the del operator operates on scalar field, then we get the gradient. So, suppose phi x comma y comma z is a scalar field. When this del operator operates on phi, then we get the gradient of phi as I cap del phi del x plus j cap del phi del y plus k cap del phi del z. From this mathematical expression, we have seen that gradient of scalar field is a vector quantity. That means it will have magnitude as well as direction. The magnitude of gradient tells about the maximum rate of change of scalar field, and its direction is along the maximum rate of change of scalar field. Now, let us understand this point through one example. Suppose we have a hot rod whose one end is kept at 100 degrees Celsius and the another end is kept at 30 degrees Celsius. The temperature gradient of this rod is defined as dt by dx. The magnitude of temperature gradient tells about the maximum change of temperature per unit length, and its direction is from 100 degrees Celsius to 30 degrees Celsius. Here you have noticed that while defining the temperature gradient, I have not shown the y and z components. It is because heat energy is flowing along x direction only. Okay? Next, let me explain the concept of divergence of a vector field. Students, we know that when the del operator operates on a vector field, then we get the divergence. Suppose f x comma y comma z is a vector field. When this del operator operates on f vector via dot product, then we get the divergence of f as del fx by del x plus del fy by del y plus del fz by del z. So, from this mathematical expression we have seen that divergence of a vector field is a scalar quantity. Next, physical significance. The divergence of a vector field tells about how much the vector field diverges or spread out from a specific point. When the vector fields are diverging from a specific point, then it is known as the positive divergence. On the other hand, when the vector fields are converging to a specific point, then it is known as the negative divergence. Again, when the vector fields are neither diverging nor converging, then it is known as the zero divergence. Next important point is that when the divergence of a vector field is 0, then this vector field f is known as the solenoidal field. Okay? Next, let us learn the curl of a vector field. Students, we know that when the del operator operates on a vector field via cross product, then we get the curl. Suppose f x comma y comma z is a vector field. When this del operator operates on f vector via cross product, then we get curl of f as determinant of I cap, j cap, k cap, del del x, del del y, del del z, fx, fy, fz. Next, physical significance of curl of a vector field. Students, curl of a vector field implies how much the vector field is curling or rotating about a point. Again, from this mathematical expression we have seen that curl of a vector field is a vector quantity. That means it has both magnitude and direction. The magnitude of curl represents the maximum circulations or maximum rotations about a point, and the direction is perpendicular to the plane of area, and it can be obtained with the help of right hand curl rule. Again, when the vector field is curling or rotating about a point in anti-clockwise direction, then it is known as the positive curl. Again, when the vector fields are curling or rotating in clockwise direction about a point, then it is known as the negative curl. The direction of positive curl can be obtained with the help of right hand curl rule, and it is coming out of this board. Again, the direction of negative curl will be going inside this board. Next important point is that when curl of a vector field is 0, then this vector field f is known as the irrotational field. Okay? The next important concept that you need to know is Laplacian operator. Students, in Cartesian form, this Laplacian operator is defined as del square divided by del x square plus del square by del y square plus del square by del z square. Next, some important vector identities. Students, I strongly recommend all of you please remember at least these 4 important vector identities. Number 1, divergence of curl of a vector field is always 0. Number 2, curl of gradient of a scalar field is 0. Number 3, curl of A is equal to gradient of divergence of A minus del square A. Number 4, A cross B cross C is equal to B into A dot C minus C into A dot B. Back cab. Okay? Finally, let me mention Gauss divergence theorem and Stokes theorem. Students, this Gauss divergence theorem gives a relationship between surface integral and volume integral, and this Stokes theorem gives a relationship between line integral and surface integral. Now, let me write these points. It gives a relationship between surface integral and volume integral. And according to this theorem, surface integration of f dot ds is equal to volume integration of divergence of f dv. Next one is Stokes theorem. It gives a relationship between line integral and surface integral, and according to this theorem, line integration of f dot dl is equal to surface integration of curl of f dot ds. Some recommended books. Number 1, Introduction to Electrodynamics. Introduction to Electrodynamics. It is written by D.J. Griffiths. Number 2, Principles of Electromagnetics. It is written by Sadiku and Kulkarni. Okay, this is all about today's video, and I hope that you have learned a lot from this video.